Advanced Math, Lesson 13, intersecting secants and tangents, products of chord segments, products of secant and tangent segments. All right, so there's two main equations that you need to memorize for these, the intersecting chords and then the intersecting secants. So again, chords, they go within a circle from one end to the other. Secants start from a point outside the circle, pass through it all the way. Now for chords, you need to remember that the interior angle, or the intersecting angle, is equal to the first arc plus the second arc divided by 2. So to solve for this unknown, we would take arc 1, which is 40, add it to arc 2, which is 80, then divide that by 2. 40 plus 80 equals 120. 120 divided by 2 is going to give us 60. So down here, x equals 60 degrees. You got to memorize that equation. You just have to. Same with this one. Now, this one is secants. Very, very similar, and this might drive some of you mad. Arc 1 minus arc 2 divided by 2. How do I know which one minus is? Well, let's start with the bigger one. The bigger arc is always arc 1. You're going to get a positive number. So we'll take 120, which is arc 1, minus 60, which is arc 2, divided by 2. So 120 minus 60 equals 60. 60 divided by 2 is just 30. So x equals 30 degrees in this one. Pretty simple. You just have to memorize these two equations, right? Next, we're dealing with more ratios as far as secants go. The first one is more common. This one's a little bit easier. The ratio is different though. So unlike our intersecting chords ratio, which was really easy and intuitive, this one is the section outside. So the section outside the circle is to the entire length of the secant, right? So for example, on the bottom here, we can say 2 is to 12, which is 10 plus 2, or the entire length, as 3 is to 3 plus x, right? And I'll do it from top to bottom because that makes me that confuses me a little bit less. So, oops, I'm sorry. I just realized I said that backwards. Okay, I'm going to actually draw it out this time. Okay, so we know that this section is 3, this section is 2, this whole length is 12, this whole length is 3 plus x. The ratio here is the top short section goes to the entire bottom section. So 3 is to 12, or 2 plus 10, as 2 is to 3 plus x, or the entire top section. From here, we're going to cross multiply. Okay. So we get 12 times 2 is 24, equals 3 times parentheses 3 plus x. Go ahead and use distributive property on this polynomial. We get 9 plus 3x equals 24. Subtract 9 from each side. 24 minus 9 is 15. So now our equation is 15 equals 3x. Divide each side by 3, and then we get 5 equals x. Alright, so this ratio is a little bit confusing. So top outside section to entire bottom length, bottom outside section to entire top length, right? So top to bottom, bottom to top, if that makes sense. All right. Now, this secant, it follows the exact same rule, but the weird part is there's no inside section on the bottom, right? That's okay. The inside section is just, think of it like this. It's just 3 plus x, or in this case, 8 plus 0. So we'll go ahead and do the same. The same thing. So we'll take x is, so the outside top section to the entire bottom section, which is just 8, is to the bottom section, which is 8, or the outside bottom section, which is still only 8, to the entire top section, which is 12 plus x. From here we cross multiply. 8 times 8 will give us 64. X times 12 plus x gives us 12x plus x squared. Alright, now we've got a quadratic. So let's see if we can factor this. We'll subtract 64, set it equal to 0, rewrite it. So we've got x squared plus 12x minus 64 would equal 0. Can that be factored? You know, it can. It can. If you remember your 4 cubed is 4 times 4 times 4. 4 times 4 would be 16. 16 times 4 is 64. Now we have a negative 64. So we could do a positive 16 and a negative 4, and that would work. So we could have x equals positive 16, x minus 4 equals 0. So the possible values for x would be the opposites of these. So positive 4 and negative 16 would be our answers. Again, though, the ratio setup is still the same. Top outer section to entire bottom outer section, which happens to be the entire length, to the entire top. All right. So once we can set up our ratios, then we can find the answer pretty swiftly.